Hello everyone, welcome back to my channel. Today we are discussing the second unit, position, from the module mechanics. It is a simple unit, some basic concepts are there to understand, so we can go ahead. So in this unit, we have to first understand what do you mean by rest and motion of an object. Rest and motion of an object. How can you say an object is at rest? An object is said to be at rest when there is no change in position of the object. When there is no change in position of the object. An object is said to be at rest when there is no change in position. An object is said to be in motion if there is a change in position of the object. So, in the coming units, these things are important. What do you mean by rest and what do you mean by motion? An object is said to be at rest if there is no change in position of the object. An object is said to be in motion if the position of the object changes as time changes. As time changes, the position of the object is changing. Then you can say the object is in motion. As time changes, if there is no change in position of the object, then you can say the object is at rest. So these are the differences between rest and motion. Another thing you have to understand, one concept, frame of reference. What do you mean by frame of reference? A frame of reference means it's a set of axes to locate the position of an object. So it is a set of axes, or it can be an object to define or to represent the motion of an object or to represent the rest of an object. So motion and rest of an object is relative. Motion of an object and object is at rest. They are relative only. With respect to another body, you can say an object in motion, an object is at rest. The trees are at rest with respect to an object. When you walk, we are in motion. We are in motion with respect to a stationary object like building, trees. So with respect to a building, you are in motion. So everything, that means the object, it can be at rest or in motion relative to another object. So when you walk, you are in motion. The trees are at rest. The buildings, they are at rest with respect to another object. So if you consider an object outside earth, everything on the earth, they are in motion. If you consider an object outside the earth, everything is in motion because earth is revolving, earth is rotating. So everything on the earth is in motion. They are in motion. For example, the buildings, the trees, they are in motion. If you consider a reference point outside the earth, but if you consider a reference point on the earth, the trees, the buildings, they are at rest. So we can't say the object is always at rest or in motion. We are defining motion and rest with respect to a point or with respect to a set of axes, and they are known as frame of reference. Frame of reference, why we are using it? Frame of reference we are using to describe the motion of an object or motion of a rest of an object. So with respect to an object only, you can say the body in motion or it is at rest. So that point is known as frame of reference. For example, if you draw the axis x and y, x and y axis, Suppose there is an object here. An object is marked as P. So with respect to the origin, the object is at a distance. With respect to this, we are using this xy axis. And with respect to the origin, the object is at a distance. So we are using a frame of reference in order to find out the location of the object, or to find out the position of the object, or you can say the object is in motion, or you can say the object at rest. So in order to explain these things, in order to find out the location of the object, in order to find out the position of the object, in order to check whether the object is in motion or at rest. So these things you can explain with respect to a set of coordinate axis, or with respect to a point, and they are known as frame of reference. So by using frame of reference, you are expressing the location of the object, the position of the object, the rest of the object, and the motion of the object. So these are described by the frame of reference. So frame of reference, it's very important when we deal with the motion of the object. So in all cases, when we explain the position of the object or the motion of the object, we are using frame of reference. Then, what do you mean by one-dimensional motion? One-dimensional motion. One-dimensional motion. One-dimensional motion simply means an object moving along a straight path. An object is moving along a straight path. For example, a vehicle is moving along a straight road. It is in one-dimensional motion. So one-dimensional motion simply means the motion of an object along a straight path. It is known as one-dimensional motion. What do you mean by two-dimensional motion? What do you mean by two-dimensional motion? Two-dimensional motion means the object motion along a surface, on a surface. The motion of an object on a surface. For example, this whiteboard, it's a surface, it's a plane. So the motion of any object, motion of a spider on this surface, this is a two-dimensional motion. So this is a surface or a plane. So the motion of any object on this surface, it is a two-dimensional motion. So what do you mean by two-dimensional? If you take your photo, it is two-dimensional. If you take your photo, it is a two-dimensional thing, because your photo is on a surface. Then what do you mean by three-dimensional motion? Three-dimensional motion. Three-dimensional motion means the motion of an object in space. For example, a bird is flying in the sky. So that is a three-dimensional motion. And when you walk, that is a three-dimensional motion. But when you take the photo of that is two-dimensional, because that photo is a surface. So there are different types of motion. One-dimensional motion. One-dimensional motion means an object moving along a straight line. Two-dimensional motion means an object moving on a surface or on a plane. Three-dimensional motion means an object motion is in space. So these are the different types of motion. Then, by using the xy axis, you can tell this is 0, 1, 2. So if I am marking x equal to 2 meter, plus 2 meter. So plus indicates the position of the object is right side. The position of the object is right side. So this marks the position of the object. it is the right side of the axis. If I mark x equal to minus 2 meter, here it is the position, minus 1, minus 2. So x equal to minus 2, it is left side of the axis, left side of the axis. So x equal to minus 2, minus stands for what? Left. Plus stands for right. The same thing you can mark here, y equal to plus 1 meter. This is y axis. So 1, 2. This is the plus 1 meter. This is the position of the object when y equal to 1 meter. Then again y equal to minus 1 meter, you can mark it. Y equal to minus 1. So this is the position where y becomes minus 1. So you can make it plus right. Right is plus, left minus, upward up plus, and down minus. So these are the position. So the position of an object you can represent on the axis. So right side is plus, that indicates x equal to plus 2 meter, x equal to minus 2 meter here. Minus stands for left. Y equal to minus 1 meter, that is down. Y equal to plus 1 meter, up. So these are the different ways you can represent the position. So in this unit, you are studying what is a frame of reference, how can you explain motion of an object and rest of an object, then different types of motion, one-dimensional motion, two-dimensional motion, three-dimensional motion, and how will you represent the position of an object, and what is the meaning of plus and minus. So these are the things we are studying in this unit.